One important application of derivatives is in the area of maxima and minima worded problems. And here are the steps that will guide us in solving such problems. So the first one is to determine the quantity to be maximized or minimized, and this is usually expressed in a variable, right? So after doing so, you form the equation for the quantity determined in the first step in terms of a single variable. So the other side of the equation must be in terms of a single variable before proceeding to the third step. And the third step is to differentiate and equate to zero. After equating to zero, we're going to solve for what is required in the problem. Right? So the most important step here is to form the equation for the quantity determined in 1, so the quantity to be maximized or minimized, and then we're going to express that one in terms of a single variable on the other side of the equation. Alright? Now, to illustrate the steps, let's have this first example. The sum of two positive numbers is 4. Find the smallest value possible for the sum of the cube of one number and the square of the other. So for this particular problem, we are going to find the minimum value, alright? So the smallest value possible for the sum of the cube of one number and the square of the other. So the quantity to be maximized here would be the sum of the cube of one number and the square of the other. So if we're going to let x be one of the number, right? So if that will be one of the number, and then y would be the other number. And for the first step, the quantity to be minimized, say we're going to let that be a, alright? So the equation formed from this statement will now be a equals x cubed plus the square of the other, so that is basically y squared. So this is now the equation formed for the quantity to be minimized. Alright, so let me just change the color of this one. So let me just change it to blue. Now, before differentiating this equation, we need to make sure that it is in terms of a single variable first. And since we have x and y in here, let us find the relationship between x and y to make this equation, particularly this side, a single variable. And where are we going to get that one? So it will be from this first statement. So the sum of two positive numbers is 4. So in mathematical expression, that would be x plus y equals 4. So solving for the value of y in terms of x, we now have y equals 4 minus x. Now, substituting this value of y to this equation, we now have a equals x cubed plus 4 minus x quantity squared. Now, one side of the equation is in terms of a single variable. So we can proceed with the next step, and the next step is to differentiate and equate to 0. So solving for the derivative of a with respect to x, this is now equal to 3x squared plus 2 multiplied by 4 minus x raised to 1 multiplied by negative 1. And if we're going to simplify the resulting expression here, so we have 3x squared plus, alright, so we have 2 times 4 times negative 1, so this will be negative 8, and then we have 2 times negative x times negative 1, so that is positive 2x. So if we just arrange this one, so we have 3x squared plus 2x minus 8. So the derivative of a with respect to x is now equal to 3x squared plus 2x minus 8. Now after differentiating this expression, we're now going to equate this to 0. So this will now be 0 equals 3x squared plus 2x minus 8. Now, since it is equated to 0, we can now solve for the values of x. And in here, we'll be having two values of x because x is raised to 2. Alright? Now, if we're going to factor out the given trinomial expression, so this will now be 0 equals 3x minus 4 multiplied by x plus 2. Alright? So now, solving for the values of x, we have x equals positive 4 over 3 and x equals negative 2. Now, if we're going to go back to the problem here, it says here that the sum of two positive numbers. So if x is one of the number and y is the other number, and the values of x that was solved are 4 over 3 and negative 2, we're going to disregard x equals negative 2. Alright, so because x and y are positive numbers. And if x is equal to 4 over 3, and y is equal to 4 minus x, alright? So from this equation, y will now be equal to 4 minus 4 over 3, or this is equal to 8 over 3. Right? So the values of x are 4 and 3, or 4 over 3, and y is equal to 8 over 3. Now, this is not yet the final answer because the quantity to be minimized is letter A. And since x and y is already determined, we can now use those values to determine the value of A, which is equal to x cubed plus y squared. So this is now equal to 4 over 3 raised to 3 plus 8 over 3 raised to 2. And bringing out our calculator here to solve for the value of A, we have 4 over 3 raised to the power of 3 plus 8 over 3 raised to the power of 2. Alright, so the value of A is now equal to 256 over 27. Or in decimal form, that is equal to 9.481. Let us have this second example here. So we have a trapezoidal gutter is to be made from a strip of tin by bending up the edges. If the strip is 11 inches wide and the base is 7 inches, what width across the top gives the maximum carrying capacity? Alright, so in this problem, it is best to illustrate the given in order for us to formulate the equation correctly. Alright, so now we have a strip of tin here and we're just going to represent that strip of tin as a rectangle. Alright, so let me just draw a rectangle in here. And if we're going to bend up the edges of this rectangle, so let me just draw a broken line in here. And on the other side as well. Alright, now if these edges are to be bent up, the appearance of the gutter will look like this one. Alright, so if this strip of tin was bent up, this is now, or this will now be the finished product. Now, the given parameters here, the strip is 11 inches wide. It means to say that this dimension is 11 inches. And the base of the trapezoidal gutter is 7 inches. So this base here would be 7 inches. Alright, now if this is 11 and this is 7, so if I'm just going to draw here a line, this length is 7. That means to say that this length, right, so from here up to this point would be 11 minus 7 divided by 2, right, so that will be 2. Is that right? So that is 11 minus 7. So this is now equal to 4. So if we're going to divide 4 by 2, so that means to say that this length is equal to 2. And this length will also be equal to 2 inches. Alright? So the length of this one is equal to 2, and the length of this one is also equal to 2 inches. So now that we are done with the illustration part, let us now determine the quantity to be maximized or minimized. Now, if we're going to go back to the problem here, what width across the top gives the maximum carrying capacity? So basically, what we are going to maximize here will be the volume that this gutter can carry. However, the volume here is dependent on the cross-sectional area of this trapezoidal gutter. And that cross-sectional area will also be dependent on the width across the top. And that is actually what we are going to find out. Alright? So if we're going to draw here the cross-sectional area of the gutter, so say for example, this is now the cross-sectional area of the gutter. So this is 7 inches, this is 2 inches, and alright, so that's redundant. So it's 2 inches, and this is also 2 inches. What would be the width across the top? Alright, now we know that the area of a trapezoid is given to be 1/2 multiplied by base 1 plus base 2 multiplied by the height. So the height is this one. So this is base 1 and this is base 2. Now, if we are going to express this one in terms of a single variable, so if we're going to substitute here, we have 1/2. Base 1 is 7 inches. Base 2, that is what we are going to find out, so that is width. And the height is also unknown here. So let me just put it there. So this is now the area. Now, we now find the relationship between the height and the width. So we're just going to find a way to express this expression in terms of a single variable. Alright? And how are we going to do that? Now, if I'm going to let this length, alright, so if I'm going to let this length be equal to x, and also, since it is a trapezoid, this is also equal to x, then I can say that the width is equal to 7 plus 2x. Right? So this is equal to 7 from this one, and this is x plus x, so the width is equal to 7 plus 2x. How about for the height? So for the height, since we have a right triangle in here, and by Pythagorean theorem, 2 squared equals x squared plus h squared. Solving for the value of h in terms of x, so we have h squared equals 2 squared minus x squared, or h equals the square root of 4 minus x squared. Now, h is now in terms of x and w is now in terms of x as well, so we can just input it here or substitute it in this equation. So the area is now equal to 1/2 multiplied by 7 plus 7 plus 2x, okay, so this is the width, multiplied by the square root of 4 minus x squared. Now, if we're going to simplify this one, this is now equal to 1/2 multiplied by 14 plus 2x multiplied by the square root of 4 minus x squared. Or 2 can be factored out here so that it will be cancelled out here. So that will now be 2 multiplied by 7 plus x. So that 2 will cancel out. A is now equal to 7 plus x multiplied by the square root of 4 minus x squared. Alright, or this is equal to 7 plus x multiplied by 4 minus x squared raised to 1/2. Alright, now we already formulated a, in terms of x only, we can now differentiate it and equate it to 0. So the derivative of a with respect to x is now equal to 7 plus x multiplied by the derivative of this one. So the derivative of 4 minus x squared raised to 1 half is equal to 1 half multiplied by 4 minus x squared raised to 1 half minus 1, so that will give us negative 1 half multiplied by negative 2x, or the derivative of 4 minus x squared. Plus, so this will now be 4 minus x squared raised to 1 half multiplied by the derivative of 7 plus x, so that's basically equal to 1. Now, simplifying this one, 2 will cancel out in here, right? So 2 will cancel out, thus leaving us 7 plus x multiplied by negative x, right? So that is negative x all over 4 minus x squared raised to negative 1 half is square root of 4 minus x squared in the denominator here, plus 4 minus x squared raised to 1 half, so that is the square root of 4 minus x squared. Right? So if we're going to combine these two terms, the common denominator would be the square root of 4 minus x squared. So 4 minus x squared, or the square root of 4 minus x squared divided by the square root of 4 minus x squared multiplied by 7 plus x times negative 1. So that will give us negative x 7 plus x. And this one divided by the denominator here, which is equal to 1, multiplied by this, so that will give us 4 minus x squared. Right? So simplifying the numerator, we have negative 7x minus x squared plus 4 minus x squared all over the square root of 4 minus x squared, or this is now equal to negative 2x squared minus 7x plus 4 all over the square root of 4 minus x squared. Alright? So, this is now the derivative of a with respect to x. Now, if we're going to equate the derivative of a with respect to x, so we have 0 equals negative 2x squared minus 7x plus 4 all over the square root of 4 minus x squared. And if we're going to multiply both sides by the square root of 4 minus x squared, we now have 0 equals negative 2x squared minus 7x plus 4. Now, solving for the values of x here, we can use the quadratic formula x equals negative b plus and minus the square root of b squared minus 4ac all over 2a. So solving for x here, x is now equal to negative b. So negative b is negative 7 plus and minus the square root of b squared. So that's negative 7 squared minus 4 multiplied by negative 2 multiplied by positive 4 all over 2 multiplied by negative 2. So if we're going to bring out our calculator here, and we're going to type in negative 7 plus, let us take first the positive square root of this one, so that is now square root of negative 7 squared minus 4 times negative 2 times positive 4 all over, alright, so that will now be 2 multiplied by negative 2. And the answer is equal to negative 4. And if this is negative, right, so the negative value of the radical expression here, so let me just put it in negative, x equals 1 half. Now, since we are talking about the dimension here, right, so since we are talking about the dimension here, we're going to disregard x equals negative 4 because there is no negative dimension. And if we're going to disregard this one, then the value of x is equal to 1/2. Now, this is not yet the final answer because the final answer would be the width across the top that will give us the maximum carrying capacity of this trapezoidal gutter. Alright, and the width is equal to 7 plus 2x. So if we're going to use that equation, w equals 7 plus 2x, and x was solved to be 1/2, then width is equal to 7 plus 2 multiplied by 1/2, or width is now equal to 8. Right? And the unit for that one would be 8 inches. Right? So if we're going to go back to our figure here, the width across the top must be 8 inches so that the maximum carrying capacity of this trapezoidal gutter will be maximum. Now let's have the third example here. So find the shortest distance from the point 5, 0 to the curve 2y squared equals x cubed. Alright, so this is also a maxima minima problem because we are going to solve for the shortest distance that is possible from the point 5, 0 to the curve 2y squared equals x cubed. And for this example, we are going to illustrate it again so that we can formulate the correct equation that we are going to derive. Right? Now we are given here a curve which is in the function 2y squared equals x cubed. So if we're going to write it down here, so 2y squared equals x cubed, we need to graph the function of this one in order for us to determine the correct equation. And graphing this function requires us to solve for the intercept. We're going to test for symmetry. And we can actually omit determining the critical points because that is not crucial in the solution of this problem. So we can just determine the behavior of the graph in each region. So for the symmetry, the x-intercept, if we're going to set y equal to 0, then x will also be equal to 0. And solving for the y-intercept, if x equals 0, then y is also equal to 0. So the x and y intercept are at the origin. Now testing for symmetry, alright, so let me just delete this one. So testing for symmetry, does it have a symmetry with respect to the x-axis? So we're going to change y to negative y. So changing y to negative y, that will give us 2 multiplied by negative y squared equals x cubed, and this is 2y squared equals x cubed. The equation remains unchanged, so there is a symmetry with the x-axis. Now changing x to a negative x, so if we're going to inspect the given function here, if this is changed to negative x, then that will give us 2y squared equals negative x cubed, and this is not equal to this equation. So there is no symmetry with respect to the y-axis. And for the test of symmetry for the origin, if we're going to change y to negative y and x to negative x, the resulting equation would be 2y squared equals negative x cubed. And this is not the same to the given function, so there is also no symmetry with respect to the origin. And now for the region in here, the x-intercept is at 0, so the region would be x less than 0 and x greater than 0. So if we're going to determine the behavior of a graph here, if we're going to substitute a value of x less than 0 here, then the value of y would be negative, or the value of y squared would be negative. And if solving for, say for example, if x is equal to negative 1, and if we're going to substitute that negative 1, 2y squared equals negative 1 raised to 3, then y squared is equal to negative 1 over 2. So solving for the value of y is equal to a value which is an imaginary. So if x is less than 0, then y is imaginary. And if x is greater than 0, say that we substitute a value which is equal to 1. This will now be the square root of 1 half, alright? And the square root of 1 half will give us a positive and negative value. So if x is greater than 0, then this is positive and negative. So the appearance of the graph, let me just delete this one. The appearance of the graph will look like this one. So if we're going to draw a Cartesian plane in here, and this is 0, say this is 5. So the appearance of the graph, if x is less than 0, so we have no graph here, and if x is greater than 0, that is positive and negative. So the graph of the function will look like this one. And taking into consideration that it is symmetrical with respect to the x-axis, what you see above the x-axis will also be mirrored below the x-axis. Now, in this problem, we are going to find the shortest distance from the point 50 to the curve 2y squared equals x cubed. And since this is the graph of the function 2y squared equals x cubed, and this is 0.50, right? So this is 0.50. The shortest distance can be drawn by a line in here. Now, this point of the function here is not known, so we're just going to call it point x and y. So the quantity to be minimized here would be the distance from this curve to 50. So if we're going to let the quantity to be minimized, so the quantity to be minimized be equal to s. So this is now s. Now, using the distance formula of 2 points here, so we have s squared equals 5 minus x squared plus 0 minus y quantity squared. Alright, so that is 5 minus x squared plus 0 minus y quantity squared. So this is now the distance formula. And if we're going to simplify this one, s squared equals 5 minus x squared plus y squared. Now, solving for the value of y, because we cannot yet derive this one with respect to x because there's still another variable in here. So, what is now the relationship between y and x? Now, the equation of the given function is 2y squared equals x cubed. So, solving for y squared, we now have y squared equals x cubed over 2. And if we're going to substitute this one in here, s squared is now equal to 5 minus x quantity squared plus 1 half x cubed. Right? So this is now the equation of s, which is to be minimized. Now, solving for the derivative of s with respect to x, or s prime, this is now 2s s prime equals 2 multiplied by 5 minus x multiplied by negative 1 plus 1 half multiplied by 3x squared. So if we're going to simplify this, we have 2 times 5, so that's equal to 10, multiplied by negative 1, so that's equal to negative 10, 2 times negative x times negative 1, so that will give us positive 2x, and this will now be plus 3 over 2x squared. So this is now 2s s prime. Now, we can already equate this to 0. So if we're going to equate this to 0, that will now be 0 equals negative 10 plus 2x plus 3 over 2x squared. Now in here, since you have a quadratic expression here, you can use the quadratic formula to solve for the values of x, or you can bring out your calculator and then change the mode to equation of a polynomial with degree 2 and just input here the coefficient. So we have 3 over 2, and then we have 2, and then we have negative 10. Right? So the values of x are negative 10 over 3, and the other one is at positive 2. Alright? Now, one value of x is negative and the other is positive. In here, we're going to disregard the negative value of x because we found out that if x is less than 0, y is imaginary. So there are no graph in this area. So we're just going to consider x equals positive 2. Right? So we're going to disregard x equals negative 10 over 3. Now, if x is equal to 2, and solving for the value of s in here, so s squared is equal to 5 minus x quantity squared plus 3, right? So that is 1 half x cubed. So that's now equal to 1 half x cubed. So if we're going to substitute 2 in here, s squared is now equal to 5 minus 2 squared plus 1 half 2 raised to 3. And if we're going to extract the square root on both sides, the shortest distance is now equal to, right? So bringing out our calculator here, changing the mode to math. So this is now the square root of 5 minus 2 quantity squared plus 1 half multiplied by 2 raised to the third power. Right? So the shortest distance is square root of 13 units, or this is equal to 3.6056 units.